Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2176, refers to the throttle actuator control system, idle position not learned, error in Honda CR-V models from 2023 onwards. This error indicates that the powertrain control module, PCM, has detected an issue where the throttle body has not successfully learned the appropriate fully closed position during its calibration process. The throttle body, which is responsible for regulating air intake into the engine, has an important role in maintaining optimal engine performance and efficiency. Its correct functioning is crucial for the vehicle's accelerator response and overall drivability. The failure to learn this position could result in undesired engine behavior, such as stalling or poor acceleration. Proper identification and rectification of this issue are essential to ensure the vehicle operates within manufacturer specifications. The primary components involved in the DTC P2176 are the throttle body and the powertrain control module, PCM. The throttle body controls the amount of air entering the engine, playing a crucial role in fuel combustion and overall airflow management. It is typically located between the air intake manifold and the air filter. The PCM, on the other hand, is the brain of the vehicle's engine management system. It processes input from various sensors, including those relating to throttle position, and adjusts engine parameters accordingly to optimize performance. When the throttle body fails to learn its idle position correctly, it indicates that either it is malfunctioning or there could be an issue within the associated wiring and connections. The PCM also requires testing to ensure it isn't registering a false condition. Therefore, it is vital to inspect both components thoroughly to identify the root cause of the DTC. Several possible causes can lead to the DTC P2176 being triggered. Firstly, a malfunctioning throttle body itself can result in learning issues. Internal damages or a buildup of carbon deposits can impede its operation. Secondly, wiring harness issues must be considered, as open circuits or shorts in the connections between the throttle body and the PCM can disrupt signals and prevent the throttle from learning its appropriate idle position. Lastly, a faulty PCM can also be a culprit, as it might not process the throttle body signals correctly or could be impaired functionally. Each of these potential issues needs to be investigated carefully, ensuring that all wiring, connections, and components are checked to pinpoint the exact source of the problem accurately. Drivers may experience several symptoms due to DTC P2176, with erratic engine behavior being one of the most common signs. This erratic behavior could manifest as inconsistent acceleration, where the engine does not respond appropriately to the accelerator pedal, causing frustrating driving experiences. Additionally, poor acceleration response may occur, leading to a lack of power when attempting to accelerate from a stop or during normal driving conditions. Engine stalling while idling may also be prevalent, often indicative of the throttle body not properly managing air intake during those critical moments. Recognizing these symptoms is crucial in diagnosing the issue correctly, which in turn assists in ensuring that the necessary corrective actions are taken promptly. The first troubleshooting step involves resetting the system to allow for an accurate examination of the throttle actuator's functions. Begin by turning the vehicle to the off position and allowing it to remain in that mode for 10 seconds. This pause allows any residual electrical signals to dissipate and clears temporary faults that may have been logged in the PCM. After the waiting period, turn the vehicle back to the on mode, which powers up the electrical systems without starting the engine. This method ensures that the vehicle's systems are prepared for the subsequent diagnostic tests. Following these steps will provide a fresh baseline from which to begin the detailed inspection process required for resolving DTC P2176. The next troubleshooting step is focused on examining the external circuit connections, notably the wires associated with the throttle body, labeled as MTR1 and MTR2. Inspect these wires for any signs of damage or disconnection, as an open circuit in either MTR1 or MTR2 can lead to an inability for the throttle actuator to learn its proper idle position. This inspection should be performed while the connectors for both the throttle body and PCM are disconnected to avoid misleading readings. The expectation is that there should be less than 1 ohm of resistance in these wires when checked with a multimeter, indicating a healthy connection. If resistance is higher or the circuit is found to be open, repairs are needed to restore functionality, as this could be a direct cause of the DTC. Following the external circuit inspection, it's crucial to conduct a visual examination of the throttle body itself. To initiate this process, disconnect the throttle body inlet hose for better access to the throttle valve. Carefully inspect the throttle valve for any contamination, such as sludge or carbon buildups. These contaminants can hinder the throttle's ability to move freely and accurately learn its idle position. In an ideal scenario, the throttle valve should be free from any substances blocking its motion. If sludge or carbon deposits are found, a thorough cleaning is necessary to ensure optimal function. Not only does this step improve the throttle body's performance, but it also aids in resolving the root issue causing DTC P2176. In this step of the troubleshooting protocol, testing involves using a known good throttle body to ascertain whether the original throttle body is at fault. By carefully installing the replacement throttle body, you can then attempt to reproduce the issues previously experienced with the vehicle. If the DTC P2176 is still present or the symptoms continue, it indicates that the issue likely lies with other associated components, such as wiring or the PCM itself. Conversely, if the symptom resolves and the DTC clears, it confirms that the original throttle body was in fact the faulty component. This methodical approach allows technicians to isolate the problem without unnecessarily replacing parts, thereby saving time and resources. The final troubleshooting step involves a thorough inspection of the powertrain control module, PCM, to determine if it is functioning correctly. Prior to conducting this inspection, ensure that all other components and circuits test within the normal range. The PCM is responsible for communicating with the throttle body and accurately processing input signals for smooth vehicle operation. Any abnormal conditions within the PCM could lead to false readings and erroneous trouble codes like P2176. If all prior checks have returned normal results, inspect the PCM for damage or faults, which may necessitate repair or replacement. Replacement of the PCM should be considered a last resort, only after confirming that other components are operating as they should be. After completing all troubleshooting steps and addressing any identified issues, the final repair verification process should be executed. Begin by clearing the DTC from the powertrain control module, PCM, using appropriate diagnostic tools. Once the trouble code has been cleared, take the vehicle for a test drive to replicate typical driving conditions. Pay close attention to the throttle response and any potential symptoms of the issue. Monitor for the reappearance of DTC P2176 during or after the test drive. If the DTC does not return, it confirms that the repairs were successful and resolves the identified fault. However, should the code reappear, further diagnostics may be needed to uncover hidden issues not yet addressed. Preventive maintenance is vital in ensuring the ongoing functionality and performance of the throttle actuator control system. Regular cleaning of the throttle body is recommended to prevent buildup of contaminants such as carbon, which can obstruct throttle movement. In addition, routine checks on all electrical connections and harnesses should be performed to identify any early signs of wear or disconnection. Monitoring the PCM's operational performance plays a key role in preemptively identifying potential issues before they escalate into significant repair needs. Keeping to a preventive maintenance schedule can greatly reduce the likelihood of encountering DTC P2176 or similar issues down the line, ensuring that the vehicle runs smoothly and efficiently for years to come. In conclusion, DTC P2176 outlines a critical failure within the throttle actuator control system that can lead to erratic engine performance if not addressed promptly. The troubleshooting process emphasizes a systematic approach to diagnosing the issue, from checking wiring to testing components like the throttle body and PCM. Each step plays a vital role in determining the source of the malfunction, leading to effective repairs and enhanced vehicle reliability. Understanding the root causes behind DTC P2176 allows technicians to not only resolve present issues, but also to implement preventive measures that extend the life of the vehicle's components. Regular maintenance and inspections are essential in mitigating future occurrences of this code and ensuring that the Honda CR-V operates at peak performance. Please like and subscribe to the channel. See you next time.